Here is a review from week 4, if you would. Some things you need to know. There'll be a couple things that are reviewed, but these are starting to be some of the things that we'll be applying in the laboratory, some of the words, and also some of the words that we apply when we live in a place like Wisconsin. First off, there it is again. Hope you have it by now. 25.4 millimeters equals 1 inch. And then segueing from that or to that, 10 millimeters equals 1 centimeter. Going back to what you probably originally learned at some point in school, that 1 inch is 2.54 centimeters. At 39.6 degrees Fahrenheit, 4 degrees Celsius, and we'll see why later, 1 liter of water has a mass of 1 kilogram. A liter is an expression of volume. A kilogram is an expression of mass. 1/1000th of a liter is a milliliter. 1/1000th of a kilogram is a gram. Therefore, the next statement really is not something that's different, or it's just a rework of the statement above, but a milliliter of water has a mass of 1 gram. We will see very often, we'll write that as rho equals 1 gram per milliliter. The last piece actually should be flipped up on top, but it's relatively new and tough for many to get. That is 1,000 liters of water is the same as 1 cubic meter and has a mass of 1,000 kilograms by virtue of the fact that it's 1,000 liters. As you get talking and discussing and looking at the basic chemistry from Carnegie Mellon open courses, the concept of a milligram per liter will come up a lot. It's quite a large concept. We will see it when we start talking about drain fields, septic drain fields, or any kind of brownfield development where you have pieces of earth that are no longer quite hospitable to build in, but which are in the center part of the city. A very large and extensive soil problem and an economic one. So we'll see things expressed in milligrams per liter. Usually when you're talking about that, it's a milligram per liter of solute or a milligram per liter of water usually. And 1 milligram per liter is the same concentration of 1 part per million. We went through that calculation in class. If a milligram is 1,000th of a gram and a liter is 1 kilogram and a kilogram is 1 liter, that's how you come up with 1 milligram per liter is the same as 1 part per million. 1/8 of an inch is approximately 1/100th of a foot. You know, of course, it's 1/96th of a foot, but it becomes one of those things that civils just need to know by rote. If you have if you have a 16th, it's a 1/200th. If you have a quarter, it's 2/100ths of a foot. Finally, that one along the bottom relates to the fact that everything we're doing is related to physics and chemistry, and that is the statement that 9.8 meters per second, or the acceleration due to gravity around here, is the same as 32.2 feet per second. That's not as exact of a conversion or an equivalence as the one at the very top. 25.4 millimeters equals 1 inch is a very exact conversion. Don't get overly confused with the survey inch and the normal inch when we talk about outside of survey. In the levels that we're measuring and building on what you've known for probably 8 years at least, or at least been exposed to, 25.4 millimeters equals 1 inch stands as is. A survey inch and an international inch, I believe, are off by a 10,000th. Check with Greg on that one. You now have a list in front of you of the prefixes that we use within engineering, science, and mathematics to express large and small numbers. And if in the middle of the page you can think of a line going across, and that one being something like a gram. A gram doesn't have a prefix, it's just a gram. A gram, by definition, is the amount of water, the triple point of water, or about 39.6 degrees Fahrenheit, that occupies 1 cubic centimeter of space. So you get to the last piece from the last sheet, if you would, that you want to know is that a milliliter is the same as a cubic centimeter. Going up the scale from the middle, a kilogram is 1,000 grams, a megagram is 1,000,000 grams, a gigagram is 1,000,000,000 grams, and a teragram is 1,000,000,000,000 grams. We usually will express these things numerically with scientific notation: 1 times 10 to the third, 1 times 10 to the sixth, or 5.6 times 10 to the sixth. And I know you have been covering that in survey, and you will cover it in problem solving, and you'll probably cover it in every class you work in. This should become common knowledge, not for just a science-based curriculum, an engineering-based curriculum. It pretty much is a fundamental part of all curriculum. Going down smaller than the gram, and I'll do it here for the meter perhaps. 1,000th of a meter is a millimeter. You already know that. 1,000 millimeters in a meter. 1,000,000th of a meter is a micrometer, or a micron. 1,000,000,000th of a meter is a nanometer. 1,000,000,000,000th of a meter is a picometer. And the term nanotechnology is sweeping, you'll see, the nation, as a lot of engineering departments look at this kind of nanotechnology in terms of building small robots or machines. Pico comes up often enough when you're dealing with minute traces. Very hard to measure for some things, very possible for others as you get into radio waves and the like. Plus, of course, we have to not forget that we all know a centimeter is a 100th of a meter. 1 times 10 to the minus 2. Remember that we measure inside an atom, or inside a molecule, and also when we talk about velocities of water through clay, we talk about angstroms, and angstroms 1 times 10 to the minus 10th meters. These things are not completely particular to distance, but the angstrom is 1 times 10 to the minus 10th meters. And finally, we looked at and talked about what a hectare is in terms of measure. It is 10,000 square meters. After seeing that hecto means 100, and so we see that the hectare comes from 100 meters by 100 meters. We also looked finally at a little bit of a basic geologic terms, and note that these terms are especially good in Wisconsin, Illinois, Kansas, and Nebraska, having been the ending places, or the places that the terminal moraines were deposited for the Wisconsinian, the Illinoisan, the Kansan, and the Nebraskan glacial ages. Knowledge that the southwest corner of the Wisconsin and the northeast corner of Iowa actually are called the driftless area. In the literature, in the common literature, and actually in the scientific literature and the geographic literature, should be basic knowledge for people in Wisconsin. It is a beautiful part of the state. Drift is soil left behind in the ground moraine, or that soil which kind of melted out and fell directly down as the glaciers slowly melted away. You will sometimes hear it used synonymously with till, but till is more likely to be the soil left behind in a terminal or medial moraine. A terminal moraine being an example of terminal moraine being that around near Amherst, and a medial moraine being the Kettle moraine, which runs up and down like a spine along the eastern part of the state, marking the actual divide between water that falls to Lake Michigan and towards the Mississippi River. And finally, a term you'll see as we start accumulating geologic terms, glacio-alluvial. In other words, soil can be both formed by a glacier and a river, alluvial meaning a river, and that's soil that'll be a little more rocky, that fell out as the water was rushing away. When these glaciers melted, they didn't all melt nice and slow. They melted fast, they melted slow, then they refroze. A lot was going on back 10,000 years ago. I will have placed out, hopefully, a radio story about some discovery that occurred recently in Europe regarding some of the last glacial ages. They talked about 30,000 years ago as a time when they had just discovered some cloth. So I hope you get a chance to read that and have a great weekend. We will be quizzing on this next week on Tuesday and Wednesday, this and the other review that we have above. So at least you know the information I will be asking.